Hello everyone, I'm Wondermaker, and today I'd like to share with you a homemade winding machine. I built this because, when working on my electromagnetic wonder before, winding coils was pure torture. Not only were my winds uneven, but keeping count of the turns left me dizzy. After much frustration, I decided to build my own winding machine. I figured, why not make it universal for both coil winding and 3D printing filament winding? And that's how this project came to be. All 3D print files, code, and the bill of materials are open source. Just hit like, subscribe, and share to grab everything in one click. First, let me introduce the basic functions. The device runs on 12V3 of power and is driven by stepper motors. The default configuration is set for 3D printing filament winding. The blue button starts the machine and the red button pauses it. Press start and the device moves to the home position and waits. Pause it again to begin winding. You use the same button to pause every zoom during winding. A short press on the red button stops the machine. A long press on the right button returns it to the 0 position. The device also features brake detection. When it detects a brake, it stops automatically. It uses an adjustable 3D printed structure to accommodate different heights and widths. It's also very easy to store. When packed up, it's about the size of a spool of filament. If you only need to wind bamboo filament, you can use it without an external display. If, like me, you want to wind out wires, just connect a screen to tweak the parameters. The system supports simplified Chinese, traditional Chinese, and English. Tap the parameter area to set values directly. Some parameters have range limits. Setting the turn count to 0 means wind until the brake. You can save up to 4 configuration files. The current setup is auto-saved on startup. For tricky wires, you can set a press pin turn count. During press pin, you manually wrap the first few turns, and the machine calculates the start position. Then tap start again to wind. This project only provides fixed and winding spindles for filament. For electromagnetic coils, you'll need to adapt it yourself. Next, let's go through the build process and a winding demo. First, you'll need to anim 17 stepper motors. You'll also need a 3-axis stepper driver board, 2 stepper drivers, and an Arduino Nano. I recommend buying steppers with dual-bond connectors so they plug right into the board. Wire them with a B+, A plus. Make sure the 6 jumpers on the top right of the board are set for full step mode. Adjust the driver current output to about 1 volt, which corresponds to roughly 1A. Set it according to your motor specs. Flash a test sketch onto the Arduino so you can see each module's response. When powered up, the motor should rotate one way, then reverse, in a loop. If not, check your wiring first. Next, make 2 limit switches. Use a normal IFN switch for the axis limit and a normally close one for brake detection. Mount this axis limit at X. When pressed, the indicator LED toggle state. Now the brake detection switch is white twice. When pressed, the LED goes off, and when released, it flashes to indicate a brake. Prepare to solve for setting buttons. Connect the start button to the control. Connect the interrupt button to C. A press on the start button causes 2 quick flashes. The interrupt button flashes once when pressed. If all tests pass and you don't plan to use a display, you then move on to the next step. Print all the 3D parts and assembly components. Some models differ slightly from the video. I made minor tweaks afterward, but differences are minimal. You'll need 4 or 5 25mm square steel rods. Next, fabricate a damped swing arm. Here's the sliding swing arm structure that allows dynamic adjustment of the spindle width. Now let's build an 8-screw guide rail. Use 2 smooth rods and 1 8-screw. All future bearings are for 610M. With enough force, miracle top and just tap it right in. Secure parts with 2 13mm dowel pins. Use 13mm Teflon tubing. The gears are self-locking, so assemble them together before insertion. Wire it up as you did during testing. Reflash the main Arduino sketch. Finally, attach the back panel that completes it. Without a touchscreen, you're free to wind Bambu filament at this point. Next, let's cover the touchscreen setup. I'm using a Taijingi touch display, which requires their proprietary ID. Simply upload the file, choose the fast battery, or it'll take ages. Use a USB cable to connect both serial ports. Because LCDs draw a lot of power, add a 5V back converter. After soldering, it looks like this. Order a custom enclosure for the touchscreen from Dell Creative's electrical store. Choose an 80 for 28mm housing, 125mm long. Cut a hole in the front for the display. Drill a tie-back port on the side. And place the order. When it arrives, it's already surface finished. The countersinks and threads are done, you can use it right away. The default parameters are set for 3D printing filament. Drill a 2mm hole in the side of the Bambu filament spool for mounting. Press the blue button to stop at the press pin turn position. Press pin 5 turns to stabilize the starting state. Press again to begin winding. If the winding gets uneven, pause, make manual tweaks, then continue. The results later aren't as good as before because the feed port and winding spindle distance changes with the number of turns. To fully solve this, you'd need dynamic distance adjustment between them. In other words, add another axis to achieve factory level quality. Finally, here's why I built this winding machine to wind coils. Don't forget to like and subscribe. I'll keep optimizing based on your feedback.